Assalamu alaikum. Today we will complete our studying for organic chemistry for chemistry IAL Edexcel AS unit 2, which is related in the same time to unit 3. In last period, after studying the oxidation of alcohol, okay, and we find how we have a mixture of chemicals by the end of reaction, we need to study how to purify the organic liquids, okay. In organic reaction, first we need to know, it's not easy to get a pure product, okay. We can't get a pure product in organic chemistry because there is many reasons. One, mixture of products will form, not one product, okay. This is one of the points, which is because we have a side reactions, okay. Usually we study the main reaction, but we have a side reaction will give us another products, okay. Sometimes as we see in the elimination reaction, there is a many possible routes for the reaction, okay. So we can get more than one product, okay. Some reactant will not react and will stay in the reaction mixture, okay. Another point, some inorganic products will form, water as example, as we see in the elimination reactions, okay. And some inorganic chemicals used in the reactions, yes, as oxidizing agent, reducing agents, sometimes catalyst, okay. We need to use some chemicals which is inorganic to help us in this reaction, okay. These take us to the purification methods. Now, the main purification methods in our syllabus in organic chemistry, we will study simple distillation, which is common, fractional distillation, solvent extraction. The first two methods, it's known for us, but solvent extraction, it's the new one. Then we have drying, and we have boiling point determination. This is our 5 methods of purification: simple distillation, fractional distillation, solvent extraction, drying, and boiling point determination. This is our methods of distillation, of purification. Now we need to know something about organic chemistry. In organic chemistry, we can't use any apparatus, okay. We need a special type of apparatus, okay. For this reason, in organic chemistry, we need a special type of apparatus. Why? Because in organic chemistry, the chemicals usually flammable and or toxic, okay. Flammable and or toxic. So we need to use a chemicals which prevent escaping of these chemical, okay, and to be trapped in the atmosphere, okay. So for this reason, we can't use a corks or bungs, okay, because it will increase the risk of leaks of these liquids or its vapors or the gases, okay. So to avoid escaping of these chemicals, which is again flammable and toxic, okay, we can use a special type of apparatus, okay. We use a special type of apparatus made of glass only, okay, made of glass only, and it can be fit together using a ground glass joint, okay. It bonded together by glass joint, okay, without any other material, to avoid its reaction or its melting due to the effect of organic chemicals, okay. Now we need to remember, and we can't use any chemicals because again, any apparatus, because we need to make sure there is any leaks or escape or for vapors or liquids while we do the experiment. Now, simple distillation and fraction distillation, it's very common. We need to know, and we use simple distillation to separate chemicals when the boiling point there's a big difference in the boiling point of the component, while fractional distillation used if the component have a close boiling point. Recall these details from our previous method, but I want from you to know two things when we compare between simple and fractional distillation. In simple distillation, it's easier to set up and quicker, okay? Easier to set up and quicker because the process take a shorter time. Simple distillation does not separate liquids as well as fractional distillation, okay? This is the main point. Simple distillation, one of advantages of simple distillation, it's easier and quicker. One of disadvantages of simple distillation, it will not separate the liquids in the same degree of purity like fractional distillation. Now, what about solvent extraction? Solvent extraction here, it's a method to separate substance from a mixture which is dissolved in another solvent, okay? So we use a solvent to remove a desired organic product from reactant mixture. Usually I like to use the example of magnet, how we can use a magnet to collect iron filling from mixture of iron and sand, okay? The magnet will attract with the iron filling, okay, and take it out of the mixture of iron and sand, okay? The same thing or something very close to this point will happen here. We will choose another solvent. Here my compound, it's already soluble in solvent, okay? Now we will choose another solvent, okay, which will take my compound, my desired compound from the mixture, okay? Like how the magnet take the iron filling from the mixture of sand and iron filling, okay? Now when we use the solvent, okay, it should be immiscible with the solvent which contains my product, okay? So two layers should form the new solvent. The new solvent should be immiscible with the first solvent which contains my desired compound, okay? This is the first thing. The second thing, desired compound should be more soluble in the new solvent. So when we choose a solvent, my desired compound should be more soluble in this solvent, okay? My solvent should be safe, available, okay, and easy to separate desired compound from added solvent, my new solvent, okay? We don't not want to face a problem how to remove my desired compound from the new solvent, okay? Again, my new solvent should be immiscible with the old one, okay? The new solvent, my compound should be more soluble in the new solvent. The new solvent should be safe, available, and easy to separate the desired compound. Now, what's my process for solvent extraction? First, we will use separating funnel. Add the first mixture. Add the mixture which contains my desired compound, okay? Then add the new solvent. Okay, so add the reaction mixture when the reaction finish to the separating funnel, okay? Then add the chosen solvent which should be immiscible, so two layers should form. One contains the organic reaction product and the other layer contains my solvent, okay? After that, what we will do, place stopper place stopper in the separating funnel, okay? Place stopper and shake the funnel. Shake the funnel, okay, while it's closed, and allow after that the content to settle into two layers again. When we shake the funnel, the two layers will mix together, okay? The two layers will mix together, okay? Then we keep the funnel without movement, without shaking, okay? So what will happen? The component will separate again to two layers. Now open the tab. Open the tab. So the first layer will go out. The first layer will go out in a flask. We called it drain flask, okay, into drain flask. This is the lower layer. The second layer, we will pour it in the separating flask, okay. Now in this layer, if we choose a good solvent, most of desired compound will be in this layer. Most of my desired compound will be in this layer. Some notes about these things. Solvent should not react with any of compounds in the reaction mixture, okay, to make sure its properties will not change. Two, it will be more effective if amounts of solvent used in small portion. For example, if we add 100 centimeter cube of solvent one time, it will not be effective like if we add 25, shake, make the separation, then add another 25, shake, make the separation of process, third 25. If we divide the solvent amount for portions and repeat it again, it will give me a better results, okay? 3, desired compound removed from added solvent. Now what we have here, when the upper layer, it's not a pure substance, contains the solvent, the added solvent, the new solvent, and my desired compound. So I have a mixture here, okay, but mixture with less component than reaction mixture. Here, if we choose a good solvent, we have only two substances, my desired compound and my solvent, okay. So to separate the component, I will choose one of two methods: simple distillation or fractional distillation, and this depends on the difference in the boiling point between my desired compound and the solvent chosen. By this point, we finish talking about solvent extraction as a purification method. Till next video, we will learn more about purification methods. Assalamu alaikum wa rahmatullah.